Hello boys and girls, this is Mr. Giomini. Wanted to come to you with about the first 6 questions of your online Topic 3 post-test. Now, this is just for practice. This will not count for a grade, but my thought is if you're successful on this online assessment, more than likely you will be successful when we take the paper pencil assessment in the near future here. So I'm going to go through these first 6 questions. My suggestion to you would be to knock out or answer the first 6 questions right now, or answer one question, and then once you've answered one question, why don't you watch the video and see if our answers mirror each other's. If they don't, maybe it's I that made a mistake and you can say, hey Mr. Giomini, I was watching your video, made a mistake, or maybe you could take a look at your work and you see that you made a mistake. So either way, great learning tool if you decide to use it in that capacity, any other capacity. So let's take a look at the first one here. It says evaluate the expression below, enter your answer in a box. So obviously I'm going to enter the answer in a box because we're doing it online, but it says evaluate. So there's the key verb, evaluate, and I'm evaluating an expression. I'm just going to rewrite this down here. So we have 8 1/10 plus 7 4/10 minus 25 divided by 2 1/2. Parentheses first. I'm going to do tenths plus tenths. Well, 4 plus 1 gives me 5. I'll bring down the decimal. 1s plus 1s, 7 1s plus 8 1s give me 15 1s. Minus 25, not 2 5/10 there, minus 25 divided by 2 1/2. All right, so let's take a look here. I have 25 divided by 2 1/2. That would be written, if I wanted to do it in the standard algorithm that we think about, we do 25 divided by 2 1/2 like this. Now the first thing I notice is I have a decimal in my divisor. Cannot have that. So that kicks over, becomes a 25. And because of that, we need to balance that move with a move over here, which gives us 250. Now wait a minute, I'm not going to do anything here. 25 goes into 25 once with nothing left over. I need to put a 0 here, place value. So, hey, 25 divided by 2 1/2 gives me 10. So now I'm left with 15 1/2 or $15.50 minus $10. $15.50 minus $10, I would be left with a whopping total of $5.50 or 5 5/10. All right, so hopefully you did that problem beforehand. Now you're able to check your answer, and hopefully you and I have the same answer. If not, maybe you have it right and I don't. All right, let's go on number 2 here. It says muffins are sold in packages of 18. Select, there's the verb, select the expressions, I see it's plural, meaning more than one, that can represent the total number of muffins in P packages of muffins. So if I were to draw a picture, there's a package of muffins, and we know that in every package there's 18. All right, now we don't know how many packages we're buying. We don't know how many packages we're buying. Let's say, and that stands for P, so let's say that I go and I buy 1 package of muffins. Well, the first expression there said, hey, if you buy 1 package, it'd be 18 plus 1, that gives you 19. Well, there's no way that if they come in packages of 18, that if I buy 1 package, I now have 19. So we know that's not right. If I bought in packages of 18 and I bought 1 package, so 18 times 1, hey, that gives me exactly 18. That would make sense. Let's say I bought 4 packages. 18 times 4. Well, that gives me 72 muffins. You know what? Multiplication seems to be a realistic answer here. So that would give me B because I'm multiplying 18 times P. That would also give me E because we are doing 18P. And when I see the number, the whole number next to the variable, I'm automatically multiplying the coefficient, which is the 18, times the variable, which is P. If I were to divide, let's say I bought 3 packages of muffins. 18 divided by 3, well, that would say I had a total of 6 muffins. That doesn't make sense about 3 packages and each package is 18. No way. And then 18 minus, again, if I bought 6 packages, 18 minus 6 gives me 12. No way that makes sense either. So we have a B and an E. And I also fit the criterion that I have expressions, meaning more than one. Let's take a look at another one here. Select, there's my verb, select each expression, each meaning more than one, that has a value that equals 36 when x is equal to 12. So I am doing some substitution here. Now, I'm going to have to go through all these and do it. Because I don't know just by staring at them. Oh, my pen went a little crazy there. By staring at them, I can't tell you. So we have 4,320 divided by 12. Divided by 12. Now, we need to get an answer of 36. Well, 12 won't go into 4, which is the thousands place in this situation. 4 will go into 43, and it goes in there 3 times. But I already have this in the hundreds place. I have to answer of 36. This gives me something like 300. I'm stopping right there. I know that's not going to work. I could stop right there. The next one says 288 divided by x, or the quotient of 288 and x increased by 16. So I have 288, and I'm going to set the divided by 12 up like this. Makes it a little easier for me to see. Now, and then at the end there, we're going to add the 16 to it. Well, let's take a look here. 288, 12 doesn't go into 2, so I can put a 0 there, hold place value. 12 goes into 28 twice, so that gives me 24. I subtract, that is 48. 12 goes into 48 4 times. Now we want an answer of 36. Well, I have 24 plus 16. Well, that gives me 40. That's not going to work. So no for you, no for you. All right, let's try and take a look at the next one now. We have x squared, open parentheses, x squared, which becomes 12 squared, divided by 18, close parentheses, plus 28. Again, I have to know that 12 squared, 12 is a base, 2 is the exponent. The 2 says use 12 as a factor 2 times. So 12 times 12 is 144. I divide that by 18, and then I add to that quotient 28. All right. Now, I know my number. I have decent number sense. Not great, not above all average, just decent. I know that 8 times 8 is 64 because I'm looking for that 4 in the ones place. Put the 6 up there. 8 times 1 is 8 plus 6. Hey, isn't that, oh, wait a minute. That gives me 144. Hey, so I know 144 divided by 18 gives me 8. 8 plus 28 gives me 36. That's the magic number we want. So that works. Yes. All right, let's look at another one here. Because it does say select each expression, meaning there's more than one. We have 1,752 divided by x minus 110. Well, I'm going to write 1,752 divided by, what's our magic number again? Oh, we're substituting in 12. Good. And then we need to subtract 110 from that. All right, now, we know that 12 goes into 17 once. We'll subtract. That's a 5. I bring down a number 5. That gives me a 4, I believe, which gives me 48. That gives me 7. Bring down a 2. That gives me a 6. And that gives me exactly 72. So there's my quotient, 146. But oh, wait, I forgot to subtract 110 from that. So 110 fewer than 146 gives me, hey, 36. That's the magic number I need. Excellent. And finally, the last one. Oh, this problem's taking me forever. But again, I want to get these right, so I'm going to go through those extra steps. I want to get the best score I can on this assessment. It says x divided by 12. Oh, wait. The quotient of 12 divided by 12 plus 36. Oh, they're tricky here. They're expecting me to see 36 here and check it. But I know that 12 divided by 12 is 1. And 1 plus 36 gives me 37, not 36. So those are my 2 answers, C and D. Again, I hope you're getting these right. I know Samantha and Jack are at home getting these right too. They work hard for me. All right, let's take a look here. The same digits are used for the expression 3 squared and 2 to the 3rd power. Select the symbol. And what they mean by this is probably a greater than, less than, or equal to symbol that correctly compares, because I want to compare the expressions. Now, this says 3 to the 2nd power is greater than, less than, or equal to 2 to the 3rd power. Okay, again, I know what they're trying to do here. They're trying to trick me because they just switched the exponents in the base, but they kept the numbers. I use the same numbers, just not in the same fashion. Well, 3 to the second power, and they're expecting you guys to go 3 times 2 is 6, 2 times 3 is, oh, they're equal. But you're better than that. You know that 3 squared is the same as 3 times 3. Is greater than 2 to the third is 2 times 2 times 2. I know Jack told me 3 squared is 9. Samantha told me 2 to the third is 8. Oh, wait a minute. 9 is greater than 8. So if I were to hit this, I toggle down. 9 is greater than 8, meaning 3 squared is greater than 2 to the third power. All right? So far, we're moving quickly. It says, choose yes or no to tell. There's the tell. Choose. If the expressions are equivalent. Oof. 8b plus 16. Is that equal to 2 times 4b plus 8. A couple of ways I can approach this problem. I'm going to do it, I'm just going to assign random numbers for b. I'm going to say b is equal to 0. That's always an easy one to do. Well, if b equals 0, I substitute in. So this becomes 8, no longer 8 times b, but 8 times 0 plus 16. Well, 8 times 0 is 0. 0 plus 16, Aspen would tell me it's 16. If we substitute in a 0 here, we have 2 times 4 times 0 plus 8. Well, 4 times 0 is 0. 8 plus 0 is 8. 2 times 8 is 16. Hey, those would be equal. But sometimes I have to put in one more than value. I can't just go for my first. So let's try another one. Let's make b now equal to 2. Let's just try it 2. And I'm going to substitute in 2 now wherever I see a b. Again, there's a couple of different approaches. I'm going to do it a couple different ways. If I do b is equal to 2, now we have 8 times 2, excuse me, plus 16. Well, 8 times 2 is 16. 16 doubled is 32. Let's see if this equals over here. So we have 2 times 4 times 2 plus 8. Well, 4 times 2 is 8. 8 plus 8 is 16. 16 times 2 is 32. Hey, this would be a yes. All right. Let's go to the next one now. This one I'll do a different way here. All right, let's see if I could do this differently here. I have 2 times 6m plus 2, and we want to know, is that equal to, or is that equivalent to 8m plus 4? I'm going to try to distribute properly with this first one. I can't combine these because they're not like terms. 6m's do not combine with 2. So I'm going to distribute properly. 6 times 2, or excuse me, 6m times 2 and 2 times 2. Well, 2 times 6 gives me 12, so that is 12, and I bring the m with me. Plus 2 times 2 is 4. Is that equal to 8m plus 4? What I want to say is no, because if I have the plus 4s the same, but the 12 and 8, they don't jive. But let's just try, let's say, hey, m is equal to 0. We'll go with our fault 0. Well, put a 0 in. 12 times 0 is 0. 0 plus 4 is 4. That works. 8 times 0 is 8. Or excuse me, 8 times 0 is 0. 0 plus 4 is 4. Hey, they're equal to. But I always want to try one more than just one time. So let's try a 1. 12 times 1 is 12. 12 plus 4 is 16. 8 times 1 is 8. 8 plus 4 is 12. No, those are not equivalent. So this would be a big no. All right. Let's try the next one. Let's go with, we have 4 times 4a plus 3, and we want to see a close parentheses, if that is equivalent to 16 plus 12a. Now, if I had Erin in here, she would tell me, you know what, Mr. Giomini, I'm looking at this here, and this can't be simplified. This is as easy to get. There's no common factor besides 1 for these two. So she would tell me, just keep that the same, Mr. Giomini. 4 times 4a plus 3. But she would say, you know what, looking at that 16 and the 12, they have a common factor, and their greatest common factor, matter of fact, is 4. So she'd pull a 4 out of both of those. And essentially you're saying, hey, 16 divided by 4 gives you 4, plus 12 divided by 4 gives you 3. But there's the 3a. There's the 3a. All right? Now, let's see what Erin would do next. She'd say these look really similar, but the 4a's here, the 3a's here, the variable is not the same. So she would know to test this. She'd say, hey, let's make a equal to 1. we'd choose something simple. Why make it harder, right? 4 times 1, when I substitute in 1, gives me 4 plus 3. Is this going to be equal to 4 times 4 plus, 3 times 1 is 3. Uh-oh, wait a minute here. That gives me 7, so that's 28. This is equal to 28. Oh, wait a minute. I always want to check it one more time. Let's go with a is equal to 2. Let's try a is equal to 2. So I'm going to substitute in now a 2 wherever I see an a. So now we have 4 times, 4 times 2 now gives me 8. 8 plus 3. 4 times 4 plus 3 times 2 is 6, right? Okay. 11. 11 times 4 gives me 44. That's 10. 10 times 4 gives... Oh, those don't equal each other. So if there's ever an instance where they don't equal each other, they're not equivalent. So this is another big no. All right, so I have yes, no, no. Okay, let's try this next one here. Oh, this problem's way too long. I'm sweating over here, I think. We have 9x minus 6 and 3 times 3x minus 2. Now, I'm guessing that Hickove would notice that, Shmi, let's use the distributive property. She'd go 3 times 3 gives me 9x. She'd see the minus sign, of course. She'd bring the minus down. She'd go 3 times 2 is 6. Wait a minute. These two are identical. So, yes, these are equivalent. And I'll just, for fun, we'll put in 0. 9 times 0 is 0. 0 minus 6 is negative 6. Negative 6. 9 times 0 is 0. 0 minus 6 is negative. Hey, those equal. Let's just try putting a 2 in there for fun. 9 times 2. 9 times 2 equals, if I put a 2 in there, b is now equal to 2. b is equal to 2. Substitute the 2, we have 9 times 2 minus 6. Is that equal to 9 times 2 minus 6? Well, I hope it sure would be because they're both the same. Right? Kind of sloppy here. Getting tired. 9 times 2 is 18. 18 minus 6 is 12. Does that equal 9 times 2 is 18? 18 minus 6, yes, that equals 12. So check. Those are equivalent as well. So that'd be a yes. All right, last question, I believe. Whew. Tell whether the GCF of the pair of numbers is 12. Greatest common factor. So we have 12 and 18. Is their greatest common factor 6? Well, let's take a look. The prime factorization of 12. Well, it is 4 times 3. But 4 is 2 times 2 times 3. 18 is 2 times 3 times 3. Factor pair in common. 2 times 3 is 6. Yes, this is true. Their greatest common factor is 6. The next one is 12 and 16. 12 and 16. Well, we already knew that 12 was 2 times 2 times 3. Well, 16 is 4 times 4, which is 2 times 2 times 2 times 2. Pair of 2s, nothing else in common. Hey, wait, their GCF is 4, not 6. I go to the next one, 18 and 27. 18 and 27. Well, the first thing I notice is 27 is an odd number. So 6 doesn't go into any odd numbers, so this has to be a no. And the last one, 30 and 54. What times what is 30? Yes, that's right, 5 times 6. And 6 is 2 times 3, and then we times that by 5 to get our 30. 54 is 6 times 9. 6 is 2 times 3, and 9 is 3 times 3. 2 and 2, 3 and 3. 2 times 3, because there's no other factor pairs in common, so for GCF we get rid of them, equals 6. That would be a yes. Hope this helps you out. Again, hope you had the right answers because you were comparing your answers to mine. All right, take care. Bye.